Let's do section 9.4, page 471, exercise 13, which reads, evaluate the improper integral or state that it diverges. For exercise 13, we have the integral from -1 to infinity of dx over x squared plus 5x plus 6. And as we've learned in this section, whenever we have infinity, plus or minus, and the limits of integration, we need to convert this integral into a limit. So this is going to become the limit as b goes to infinity of the integral from -1 to b of dx over x squared plus 5x plus 6. And now we're ready to evaluate the integral. And when I look at this, I think of partial fraction decomposition. So I need to factor the denominator, and that's going to be x plus 3 times x plus 2. And of course, I break that into two fractions. So I'm going to have a over x plus 3 plus b over x plus 2. And then I find a common denominator again of x plus 3 times x plus 2. So I'm going to have a times x plus 2 plus b times x plus 3. And this is going to be 1 over x plus 3 times x plus 2. And now, because my denominators are equal, my numerators have to be equal too. So I'm going to have 1 is going to be equal to a times x plus 2 plus b times x plus 3. And what we often do in these situations is to choose our values for x cleverly, and then we can figure out what a and b are. So I'm going to let x be equal to -2. And then I'm going to have 1 is going to be equal to a times 0 plus b times 1, or we're going to learn that b is equal to 1. And then I'm going to let x be equal to -3. So I'm going to have 1 is equal to a times -1 plus b times 0, or I'm going to have a is equal to -1. And now I'm ready to get back to my integral. So I'm going to have the limit as b goes to infinity of the integral from -1 to b of negative dx over x plus 3 plus dx over x plus 2. And we know what the antiderivative of these two pieces of the integral are going to be. So I'm going to have the limit as b goes to infinity of the negative natural log of x plus 3 plus the natural log of x plus 2, evaluated from -1 to b. And I want to combine these natural log terms before I substitute in. So I'm going to have my limit as b goes to infinity of the natural log of x plus 2 divided by x plus 3. And we're going to evaluate that from -1 to b. And now I'm ready to substitute in for my limits of integration. So I'm going to have my limit as b goes to infinity of the natural log of b plus 2 over b plus 3 minus the natural log of 1 over 2. Well, now we can evaluate the limit part as b approaches infinity. And as I look at this part, when b approaches infinity, all that's going to matter are the leading terms, which are going to be b's if I use end behavior modeling. So this is really going to go to 1 as b goes to infinity. And we know that the natural log of 1 is going to be equal to 0. So my integral is going to be the negative natural log of a half. And of course, I don't like that negative sign in front, so I'm going to use it as an exponent, which means I can flip my fraction here, and this is going to give me the natural log of 2, and that is what my integral will converge to.